Okay, welcome to lesson 91, rational and irrational numbers. So I believe this is the last video in a series beginning back with lesson 86. So please go back and watch lesson 86 up to this one if you haven't already done so. And welcome to this channel if this is your first video. Here's our objectives, our vocabulary, and you can always pause the video and watch it here on your own. So let's talk about the number system. We have rational numbers, integers, whole numbers, and natural numbers on the left, and irrational numbers on our right. So pi is a math number dealing with the ratio of line segments in a circle. I'll just leave it at that for now until we get to geometry. It's the radius, the center to the edge of a circle, due to its outer circumference around us. So we'll worry about that later. There's also another number E, which will be used in chemistry, which is an irrational, non-repeating, non-terminating decimal. There are a couple other constants. I will have to think about them, especially when you get to chemistry, Planck's constant and Avogadro's number and other things like that. But I'll worry about that at a later time. Just some irrational numbers. Pi, E. I'm trying to think if there are any others. I can't think of them right now, but I will mention them in later videos. Okay, so let's square these numbers for our first example. So 3/8 squared. So what I'm going to do is 3 times 3. And then 8 times 8. This is not, when you square a number, it's the same as doing 3 over 8 times 3 over 8. You got to multiply the number by itself, not multiply the number by 2. I want to talk about this one. What you're supposed to do technically is square the number and then multiply the negative separately. So this one will be get negative 49. This is odd. If you type this in the calculator like this, it will do 7 squared first and then do the negative, and you'll get negative 49. Now for negative 7, this is the same as negative 7 times negative 7, which gives you 2 negatives, which is even, gives you a positive 49. So be careful if you're using a trusty calculator and you cannot figure out why there's a difference between these two. What the calculator will do is do the exponent first and then the negative. And because there's only one negative on a second example, it will square and then do the negative. Since I've already answered these questions here on this slide, I'm going to finish the first one. So 3 times 3 is 9, 8 times 8 is 64. And I would like you to reduce this fraction from here. Let's see, do they have anything in common? I believe they have a 3 in common. So divided by 3 over 3. 9 divided by 3 is 3. 64 divided by 3 does not go into it evenly. So we can divide by 9 over 9. No, 54. 54, 63. So there's no reducing this fraction. There's no reducing this fraction. So 3/8 squared is 9/64. Okay, for each number, list all the terms that apply. So let's see. Our second example here. All right. This one is rational. The square root of 45. Is that a perfect number? Let's see. 6 times 6 is 36. 7 times 7 is 49. The square root of 45 is not a perfect number, so that would make that irrational. 01, 02, 03. The numbers do not repeat, and these dots mean that they do not terminate. So this is irrational. Um, 358. There are no dots at the end of this number. It can be made a fraction by putting a 358 over 1,000. And so because it can be made a fraction, this is rational. And we saw this a couple of videos ago, so this repeats. This problem is an example at least. Let's look at our next example. Okay, so let's look at our third example. The square root of 400 and the square root of 90. So find each square root. Find two consecutive integers which the square root would fall. Well, the square root of 400 is easy. That is 20. So 400 is a perfect number from our multiplication and or perfect square chart. 90 is going to be a little different. So 90 is in between the square root of 81 and the square root of 100. So the square root of 81 is 9. The square root of 100 is 10. So 90, the square root of 90 is going to be somewhere in between 9 and 10. It's going to be 9 point, let's see, it's 10 away from 100, is 9 away from 81. So it's going to be about 9.4. And if you wonder where I got this 9.4 number from, please go back and watch Estimating Square Roots. I intend for you to watch everything from 86 to this video together as a series. Those are our three examples. I will see you at the end of the video for a recap. Okay, well, solving the problems. 0.7 times 0.7. We know 7 squared is 49. So let's just write it out. Let me make this a little bit smaller. 0.7 times 0.7, which gives us 0.49, because I have two numbers behind a decimal place. 9 over 4 squared gives us 81 over 16. The square root for the factors of 16 are 2, 8, 2, 4, 8, and 16. The factors of 81 are 9 and 9, which is 3. They have no common factors, so this one can't be reduced. But what we can do is simplify this fraction. Let's see. 16, 32, 48, 64, 80. So 5 times 16 is 80, and 1/16 left over. So if you forget your 16 tables, you can look on the multiplication chart, or you can go back to one of the fraction videos dealing with improper numbers. 8 squared is 64. There's a negative on the outside. This gives us negative 64. Let's look at our next problem. Problem 2. So this is supposed to be the square root of 22 over 7. 22 over 7, the square root of it. That's the negative square root of 144. So list the terms that apply. 22 is non-perfect, 7 is non-perfect. If you divide 22 by 7, you get 3 something, and the square root of 3 is non-perfect. So this would be irrational. The opposite of the square root of 144. We don't have to solve it. We know that 144 is 12, so this would give us a rational number. 102 is not perfect because 100 is perfect, and so this one is irrational. And so what I'm trying to drill down into you that the roots of non-perfect numbers are irrational, and our perfect numbers are on a diagonal on that chart. You might want to highlight them in 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 17 times 17 is 289, 324, 361, 400. So you might want to highlight these numbers so that you have them in memory. And our final example. For each square root, if the radicand is non-perfect, find 2 numbers. So, square root of 104. We already talked about this on the perfect page. The square root of 100 is 10. The net one next to it is 121, which is 11. So, 104, the square root of 104 would fall between 10 and 11. It's closer to 10, so I would say like 10.2. About. The square root of 128 is non-perfect, so 121 is 11. The square root of 144, which is next, is 12. Is closer to 121, so it'll probably be about 11.2. So all we were looking for, honestly, was the 2 numbers where the square root will fall, and we found them, and that is our video. If you like what you saw, please subscribe, hit the notification bell for more videos, share it out, and continue to watch for more videos. Again, this video should be the last in the series dealing with squares and perfect numbers and non-perfect numbers, which I believe started at video 86. So thank you for coming.